Hello, everyone. In this lesson, I will guide you to learn about the application of jump and label instructions. In industrial robotics programming, jump and label instructions are primarily used to make the program jump to a specific label section based on changes in conditions. These instructions are often used in conjunction with specialized functional requirements. In this lesson, we will integrate the selection program functions we previously studied to learn how label instructions are applied. In industrial robotics, it is often necessary for robots to perform comparison and judgment tasks to determine the next action to execute, ensuring better alignment with production requirements. So, how do industrial robots decide what to do next? The topic of this lesson, application of jump and label instructions, provides a clear solution to this question. We will explore this topic through the following three sections. 1. Label instructions. 2. Jump instructions. 3. Screen recording demonstration. By the end of this lesson, you should be able to 1. Provide a brief overview of label instructions and jump instructions definitions. 2. Independently practice and master the practical application of label instructions and jump instructions through recorded demonstrations. First, let's start with label instructions. The label instruction, LBL-I, is used to represent the destination of a program transition. Labels are defined using a specific label definition instruction. Additionally, comments can be added to labels for clarity and better understanding. Labels, once defined, can be used in both conditional and unconditional transitions. Labels cannot be indirectly referenced by their numbers. Place the cursor on the label number and press Enter to input comments. The range of label numbers is from 1 to 32,766, allowing up to 32,766 unique labels. Comments can include up to 16 characters, such as numbers, letters, asterisk, underscore, etc. Next, let's look at Part 2, Jump Instructions. The jump instruction, JMP-LBL-I, allows the program to transfer execution to the label specified within the same program. Jump instructions must always be used in combination with label instructions. Next, I will operate the computer and use the FANUC simulation software RoboGuide to perform a simulation. This will allow everyone to understand the practical application of label instructions and jump instructions. First, create a new program called Exercise 32. Click OK, and select Edit. After entering the program editing interface, we begin editing the conditions. We typically use changes in numerical values to determine program jumps. Here, bring up the R calculator and use its numerical changes to select the jump destination label. Select R5 calculator as the conditional value for the jump and set its initial value to 0. Next, following standard programming practices, we first set the initial movement of the robot to the reference work origin PR1, which is a variable in the global data memory. Then, we name the subsequent program segment with a label. The label instruction is used as follows. In the instruction menu, select the fifth option, Label and Jump Instructions, which will display the available instructions. The first option is the jump instruction, and the second is the label instruction. These two instructions are used in combination with one another. We first select the label instruction and name the program segment starting at the third line as LBL1. Next, call the Select program. Based on the previous lesson, we use the value of R5 as the condition for making decisions or selections. If R5 equals 0, the program should jump to LBL2. Similarly, we need to copy another program segment so that if R5 equals 1, the program will jump to LBL3. Next, we will begin writing the program segment starting at LBL2. Name the program segment starting at line 6 as LBL2. Here, assume the robot needs to move to a specific position and record the motion point for its movement. When the robot completes this movement, we end the motion and adjust the value of our register by programming it. Increment R5 by 1 to act as the next condition for decision making. After the robot finishes this motion point, it will return to LBL1 using the jump instruction, JMP. The logic of this program is as follows. When the robot determines that 25 is equal to 0, it executes the program segment starting at LBL2, running until it reaches the designated work point. After completing this motion, it will jump back to LBL1 to evaluate the status of R5. At this point, R5 has already been incremented by 1, so on the first return, R5 will now be 1. Therefore, the next program segment to execute will be the one labeled as 3. Since this new program segment is similar to the previous one, we can use the copy-paste method to duplicate the previous program segment and then make the necessary modifications. Move the cursor to the desired paste location and select the paste logic. Here, rename the label to LBL3 so that line 10 marks the beginning of the LBL3 program segment. At this point, we need to record a limit work point P2. Note that P2 is just a placeholder position point without any data information. First, select the robot and record the location of P2. Set this point as the robot's PL point. Press Shift plus touch to record this point. After executing this point, we have successfully completed the execution of 2 label program segments. Next, end this program segment. Since there's no need to jump back to LBL1, delete the unnecessary program code. After that, make the robot return to the initial work point PR1. This completes the programming process. Let's review the program. The entire program is structured around evaluating the status of R5 to determine which program to execute. When the initial value of R5 equals 0, the first program segment checks the condition and executes the program starting at LBL2. From there, the robot moves to the designated work point P. After completing this motion, R5 is incremented by 1, and the program jumps back to the third line to recheck the condition. At this point, R5 becomes 1, so the program jumps to LBL3. The robot will move to the work point P0. After execution, the motion ends at the work point, and the robot returns to the initial work origin. The program then concludes. This represents the process and functional requirements of our programming. Next, let's run this program and observe its effect. First, return to the initial work origin, evaluate the condition, and execute the first program segment starting at LBL2. Then execute the second program segment starting at LBL3. Finally, return to the initial work origin. This demonstrates the application of label and jump instructions. Okay. In this lesson, we explored the application of label and jump instructions in combination with the select program. These instructions are widely used in applications involving function and mode selection. In practical applications, the value of R5 is often assigned through the upper-level controller. This allows us to configure the robot to execute specific programs or functions via the upper-level controller, thereby achieving functional selection. This concludes our lesson. I encourage all of you to practice further to become proficient in the use of jump and label instructions and their practical applications. Thank you for your attention, and see you next time.